Hi there guys, and welcome to this video on equations, but this time we're going to look at all the different types of equations that you've seen in your first year. Now, there are lots of different types. There are three-term equations, that's how we started the year, and then we started recently to introduce those with brackets. We have four-term equations, so x is on both sides, and then we can also put those with brackets just to make it even harder. And we have normally three terms, but with fractions, and it won't be until next year you have four terms with fractions. Nothing to fear, they're all the same method. What you do to one side, you do to the other. Try and get x's on one side, numbers on the other. No different. So let's just go through them all, and let's start with the ones we've done most recently. So, on the left here, we have a three-term equation. 1, 2, 3. The x's are all on the left, there are no x's on the right, so I could write plus no x's if I want to make it a four-term one, but there are no x's on the right, so x's are on the left, the number terms need to be on the right. So we need to get rid of this minus 1, so we're going to add 1 to both sides, and that will leave us with 7x is equal to 14, and we're pretty happy, hopefully you are anyway, with this type of question now. So divide by 7 because we had 7 x's, so x would equal 2. My equals in a nice line. I've got my definite left hand side and my right hand side. Structure is the key. Okay, when we move over to the right hand side, we've got x's on both sides, so we need to make it look like this. X is on one side, number terms on the other. So 4 terms to 3 terms to 2 terms to solve. So to do that, because there's 2x on the right hand side and that is the least amount, I'm going to subtract it to both. That will give me 6x's. The 5 will be unchanged. The 2x is going to disappear, so no x terms, and you can see it's now a three-term equation. So we just repeat this process as we did before. So the x's are on the left, the numbers need to be on the right, so we need to get rid of this minus 5. We're going to subtract it to both sides because subtracting 5 is the inverse of adding 5. Equals in a line-ish. So the 5 is going to disappear, leaving me with 6x. The 23 take away 5 is going to give me 18. And you'll notice when there's an extra term, you get an extra line of working. But nothing to fear. Divide by 6 to both sides because we have 6 x's and we get 3. So when you lay out your work, it must look just the same as mine. Right, that is how you make fewer mistakes. Okay, so let's do 3 and 4 term with brackets. Now, I think a good habit to get into is just to expand the brackets. Because this is 5 times, you can actually divide by 5 first. That's going to make it really easy. But let's just expand them because you can't use that method on these. So let's just stick to one method for the first year and then make it a bit more complex as we get a bit older. So expand the bracket, 5 of these brackets, we're going to have 10x plus 15 is equal to 50. So we're going to subtract 15 to both sides. That's because the x's are all on one side already, so we don't need to move those. What's that going to give me? 35. Okay, so divide by 10 because we've got 10 x's. We only want one of them, and that would be 3.5. Or you could write 35 over 10. That's also fine. Okay, so let's expand the brackets. So we have 6x plus 12, but this time we've just got 2 brackets. So 12x minus 4, don't get caught out by the negative here. Which side has the most x's? Well, the right hand side. It has 12, the left only had 6. So let's subtract those 6 x's from both sides. Means this time we're going to be collecting the x's on the right hand side. So let's put my equals. I will only have a 12 left because the 6 x's are going to go. My 12x take away 6x, that's going to give me 6x, and the minus 4 be unchanged. Okay, x is on the right, x is on the right, so the numbers need to be on the left. This time we have a minus 4 which I need to get rid of, so I add 4. I must do the opposite. So I end up with 6 x's is equal to 16. That's non-friendly. 16 is not a multiple of 6. We're going to divide by 6 anyhow. And what I'm going to do is just write 16 divided by 6, or 8/3. I wouldn't go to mixed, they're just not really that helpful, so that's fine. You can go to mixed as well, it's not a problem, but I'm not going to. Okay, so now let's start dealing with fractions. Now I wouldn't even call it, I said there's two variations at the start, but I wouldn't call these those because you don't have to do anything apart from think here. So a number divided by 4 is 32. So you just go through your 4 times table basically, and it's 32. Now, x is being divided by 4. The opposite or the inverse of dividing by 4 is timesing by 4. That's what you have to do to get rid of the divide. So you have to do it to both sides because we have an equation. So 8 times 4 is 32. I think it's just easier to look. This one as well is definitely harder. This is definitely harder when x is on the bottom, especially to adopt our formal methods. But 12 divided by something is 2. Obviously that something is 6. Now, when x is on the bottom, what I want you to do is just look at it. Okay, not to do anything fancy, we'll worry about that next year. Okay, now these are the two types of fraction equations you're most likely to get. There will always be 3 term, so 1, 2, 3. I'm calling this, and here we go, is 1, 2, 3. You might think, well, there's another term here. Why is he only calling this 3 terms? But the 5x is being divided by 9, and the 3 is also being divided by 9. That's just a more convenient way of writing it. So this is actually 3 terms as well. So if you get stuck with these, what I would say is go back to your younger days when we played the I'm thinking of a number game. And you would say, I'm thinking of a number, x, call it x, so don't know what it is, times it by 5, take away 3, and then I divide by 9. And I get 3 as my answer. And you would naturally unpin it. So if you're ever unsure with fractions and equations, always play the I'm thinking of a number game. So what was the last thing I said? I divided by 9. So I have to times by 9. Another way of looking at it is, what is the last thing happening to this x? Well, the first thing is being times by 5. Then it's having 3 taken away. Then it's all being divided by 9. So that's how I have to, that's basically the same thing, but without playing the game. So you have to undo the last thing happening to it. So if I multiply both sides by 9, the left hand side, by doing that, I get rid of the divide by 9. I see a lot of people now timesing all of these by 9. You've actually times the left hand side by 81 if you do that. And the right hand side, I'm going to get 27. And you can see we're back to happy ground, normal 3 terms. So add 3 to both sides. I'm going to talk less for this bit now. Equals 5x is equal to 30. Divide by 5 to both sides. X equals 6. Okay, now you'll notice the one on the right is slightly different. The fraction line is less lengthy. Okay, if we're going to play the I'm thinking of a number game, we would say, right, I'm thinking of a number, let's call it x. I times it by 4. I then divide by 10. That division is happening earlier this time. And then I add 1. The last thing happening to this x on the left hand side is adding 1. So we have to subtract 1 to both sides. I don't like where I wrote that one. So you can see the first one, I got rid of the division first because it was the last thing happening to the x. The division isn't the last thing, the plus 1 is. So that's what I got rid of first. I always remove the last thing happening to the x. Equals in a line. I'm going to end up with 4x divided by 10. And 3 take away 1 is 2. Okay, now what is the last thing happening to this x? Well, it's been times by 4 and then divided by 10. So I need to get rid of the dividing by 10. So that will leave me with 4x to get rid of the dividing by 10. And 20. So x would be 5 once we divide by 4. Okay, the ones on the left are more common. I don't think you're going to really like these because it's been a long time since we've seen them. So let's do another 2. And pause the video, have a go, hit play when you're ready. Okay, so welcome back. Hopefully you're going to get a warm fuzzy feeling when you get these right. If not, don't worry, it will come. So what is the last thing happening to the x? Well, it's being times by 6 first, then having 2 added to it, and then divided by 19. So we're going to times by 19 to get rid of that. If we do that, equals in a line. The divide by 19 is going to go, because we've done the inverse to that, and we're going to get 38 on the right hand side. Now we're in happy grounds. 6x plus 2 is 38. Let's remove the 2. We end up with 6x equals 36. Nice friendly numbers. So we're going to divide by 6. Didn't mean to change colour there, but it doesn't matter. And we get 6. On the right hand side, slightly different looking. What's happening to the x last? Times by 7 is first, then divide by 3, then adding 4. So we need to remove the adding of 4 by subtracting. So we're going to end up with 7x divided by 3 is equal to 7. What is the last thing happening now? Well, it's been times by 7 and then divided by 3. So we're going to times by 3 to get rid of it. When we times by 3, the dividing by 3 is going to disappear. And we're going to get 21 on the right, and I think you can all see that this is 3 when we divide by 7. Okay, so I've got no more examples. They are all the different types. You've got to be really happy with them all. So let's practice, 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 and then we can move on next year. All right, best of luck, everyone.